Martian days, the mission clock was ticking. Each Sol, the name given to a Martian day, which runs 24 hours and 39 Earth minutes, saw the same routine. The researchers began with a science assessment meeting, with each science theme group, the rock experts, the soils people, the atmospheric specialists, describing what they were seeing in the new data and images just in from Mars.
This type of interaction that occurs is a necessary part of science. It involves a lot of debate amongst your colleagues.
Based on the position that we're at right now,
Squires sensed that opportunity might be poised for significant discoveries. He sketched out a campaign that would deploy all the scientific weapons in their arsenal.
I believe that this is an excellent opportunity to do a comprehensive, multispectral, high spatial resolution, the best that PanCam can do on El Capitan. So I would request that the geology theme group design that.
Yeah.
Okay.
Tackling the big questions about water and habitability now came down to logistics and scheduling the instruments. It was clear the microscopic imager, or MI, would be key.
We put in for the 5 MI. First one is on the what we call the upper MI part. We've broken it into 3 parts.
I'd like to propose an experiment, and this seems like the ideal time and place to do it.
Some ideas, though good, might have to wait.
You have to formulate hypotheses and present tests of the hypotheses. And so what we do then is have enough discussion in the group. We limit it to a restricted amount of time. And after that time, we basically look for a consensus view to emerge. And when it does, that's the path that we take.
Now is the time to send Opportunity's rat into action.
What we plan to do is drive over to the front of El Capitan, stay away from it from about 1.5 meters away.
Scientist Steve Squires wanted engineer Eric Baumgartner to know exactly what was needed to make the Eagle Crater campaign successful.
And we want to be able to rat here, just in this one spot.
Made a good start
Wheels here
on this. Just that maybe these would be
wheels here.
We make our best engineering guess at what's going to happen. So we take panoramas around us with these navigation cameras on our top of the mast, generate range data. From that range data, create 3D terrains of the environment. And so we can drive the rover on the terrain, just like we hope it's going to drive there, and we can see how the rover is going to be pitching and rolling, and use that information to say, okay, when we're driving from here to here, this is the change in slope. As we change that slope, we can figure out along the way how much we expect the vehicle to slip, and so we it's almost like a golf ball on a putting green. You know, you have to take into account the slope of the green. So if you want to hit this spot, you got to putt it up the hill so it comes down and curves down into the hole.
Yeah, that is exactly Oh yeah! I mean, we had downhill slip, we had side hill slip, we had uphill slip.
This was a hell of a drive. Nice job, Mr. Baumgartner and Mr. Bajadek.
To me, it's like landing day. You know, landing day, everybody sees the images, and it's, you know, everybody breaks into cheering and screaming and yelling. And for me, that was the same kind of feeling. You know, here we did this long, very complicated traverse across the terrain, and when we got there, bam, there's the thing we're looking for right in front of us.
After a journey of 500 million kilometers from Earth to Mars and a 16-meter drive on slippery sand, Opportunity comes within centimeters of where they want to be.
As we're speaking, the rover has actually come right up to this position with its front wheels about here, and we are going to be able to put the instrument arm first on a spot right about here, and we will be able to put the microscopic imager on it. That's like taking a hand lens and getting a close-up view of the layering of the rock and the nature of the grains. And then we're going to use 2 of our other instruments, the Mossbauer spectrometer and the X-ray spectrometer, and they will give us mineralogical information on any iron minerals that are in here, and chemistry, that's the elemental chemistry of this. So at that point we'll have a first-order picture of the physical and chemical characteristics of this, but then we're going to take our instrument called the RAT and give us a fresh surface, and that way we can do the same chemistry again and tell whether or not the surface is actually affected by either dust or an